Hello student, welcome to my channel The Learn Physics. Today I will be discussing the first part of motion of class 9 Cbse chapter 8. Now today's discussions are first of all rest and motion, scalar and vector quantities, then displacement and distance, speed and velocity, and finally acceleration, and all the numericals of ncert related to these topics. Now let's start. In our daily life we observe that car is moving, the bird is flying, and a person moves. So they are changes their position with respect to their surrounding. So they are in motion. We also observe tree, electric post, our house. They does not change their position with respect to their surrounding. So they are in rest. Before discussing the motion, first of all, scalar quantities and vector quantities. In physics, some quantities like displacement, velocity, momentum, force, torque, electric field, magnetic field, etc. have magnitude and directions. These physical quantities, which have both magnitude and directions, are called vector quantities. And the other quantities like distance, speed, energy, work done, electric current, etc. These quantities have only magnitude. So these quantities which have only magnitude are called scalar quantities. Now, what is the difference between vector quantity and scalar quantity? First of all, vector quantities have both magnitude and direction, but scalar quantities have only magnitude. The vector quantities are added or subtracted with the help of triangle law of vector addition, but scalar quantities are added or subtracted by algebraic method. Now, the magnitude of sum of two vectors depends on angle between them. The magnitude of sum of two scalar quantity is always constant. Okay. Now, a reference point. A fixed, suitable and convenient point is taken to consider the motion of a body precisely. This point is known as a reference point. This point may be on the surface of Earth, may be on the moving train. Okay. Now distance. Distance is the path length traversed by a moving particle. Look at this. Suppose a particle move from A to B in the path ACB. So total path length ACB is the distance traversed by the particle. It is a scalar quantity and its SI unit is meter. Now displacement. Displacement is the shortest distance between initial and final point. Look at this. This is the initial position of the particle and this is the final position of the particle. So shortest distance between A and B is the displacement. Okay, and this is the distance. If the motion is not done in straight line path, look at this here, displacement is less than distance. If the motion takes place in a straight line path, then both displacement and distance are equal. It is a vector quantity and its SI unit is meter. Okay. Now take another example. Suppose a particle move from O to A and then B and finally at O. Here OB equal to, this is the 500 meter and AB equal to also 500 meter. Okay, look at this from O to B. From O to B, distance equal to 500 meter and displacement also 500 meter. So look at this. If the motion takes place in a straight line path in same direction, distance and displacement are equal. Now, from O to A, distance is 500 plus 500, that is 1000 meter, and this also 1000 meter. Okay. Now, from O to A, then B. What is the distance covered? Look at this. This is the 500. This is the 500 and again 500. So, distance is 500 meter. Okay. Now, what is the displacement? Displacement is the shortest distance between initial point and final point. Because B is the final point, so this distance is the displacement. So, this distance is the 500 meter. So, this is the 500 meter. Okay. Now, look at this from O to A, then again O, then again O. Look at this. Here distance, this is the 500 meter, 500 meter, 500 meter, 500 meter. So, distance is 2000 meter. And displacement, look at this, initial point and final point same. So, here displacement is 0. Now, look at this, another point, suppose this is the C. If the particle moves from O to A, then again C. Here O to A, then A to C. Look at this, distance covered, look at this. Look at this, O to A, this is the 1000 meter. And this again 1000 meter, 2000 meter plus 500 meter. So here distance is 2500 meter. Okay. And look at this, displacement is opposite direction. So this is the minus 500 meter. Okay. Understood? From this discussion, we sum up the difference between displacement and distance. Look at this. First of all, distance is the path length traversed by a body. And displacement is the shortest distance between initial and final point. Okay. Next, distance is a scalar quantity, whereas displacement is a vector quantity. Next, look at this, distance never be 0, but displacement may be 0. The distance covered by a moving body always increases, but displacement may or may not increases. Look at this, distance never negative, but displacement may be negative. Understood? Now we discuss some common question relating to displacement and distance. Okay? Question number 1. If a moving body covers a distance, can it have 0 displacement? Give an example. Look at this. If the particle starts along this direction and again reaches this point, that is initial and final point is same, then displacement 0. Otherwise, if the particle moves in a same line in same direction, then displacement and distance are equal. Okay? Which is correct about displacement? Will displacement never be 0? No. Displacement may be 0 if the initial position and final position of a moving body is in the same. Displacement always greater than 0. Is it correct? No. As the displacement is the shortest distance between initial point and final point. So, displacement may be equal to distance in a straight line path, but in other path, displacement less than distance. Okay. Now, look at this. An athlete moves round a circular track of diameter 200 meter in 40 seconds. We have to calculate the distance and displacement in 2 minutes 20 seconds. Look at this. Time t equal to 2 minutes 20 seconds means 2 into 60 plus 20 seconds, because 1 minute equal to 60 seconds. So look at this. This is the 120 plus 20. So this is the 140 second. Now look at this. 140 can be written as 40 second plus 40 second plus 40 second plus 20 second. Look at this. So in 40 second, athlete moves one round. Next 40 second moves another round. And next 40 second final round. Now next 20 second. Look at this. For one round, time required 40 second. So in 20 second, it covers half round. So if O be the starting point, the athlete moves finally this to this distance after 3 round. Athlete finally completes 3.5 round. What is the distance? Look at this. The perimeter of the track, perimeter equal to pi into d. Now pi, this is the pi means 3.14 and d equal to 200. So this is the 6 to 8 meter. Okay. So look at this. In one round, athlete covered the distance 6 to 8 meter. So in 3.5 round, total distance d equals to 3 whole half into 6 to 8. That is, this is the 7 by 2 into 6 to 8. Now this and this is the 314. Now multiply 314 by 7. Now look at this. 7 into 14, 98. 7 into 3, 21. So distance covered is 2198 meter. Okay. Now displacement. Look, the athlete has initial position A and final position B. So the shortest distance between this and this point is the displacement. So look at this. Displacement is equal to diameter, that is the 200 meter. Okay. During morning walk, a person walks 3 kilometers along east and then 4 kilometers due north. Find magnitude of displacement with respect to the initial point. Now look at this. Suppose this is the starting point. So this direction is the east, this is the north, this is the west, this is the south. Now person moves 3 kilometers along east. So this is the 3 kilometers. And suppose this point is A point. Then moves 4 kilometers due north. So this is the 4 kilometers due north. So this is the 4 kilometers. If B be the final position, so AB is the 4 kilometers. Now what is the displacement? Displacement is the shortest distance between this point and this point. So OB is the, look at this, OB is the displacement. We have to calculate OB. Now look at this. OAB is the right angle triangle. If OAB right angle triangle, look at this. This is the base, this is the perpendicular, this is the hypotenuse. So applying Pythagoras theorem, we know OB square equal to OA square plus AB square. Now what is OA? Look at this. OA equal to 3 whole square. OA, what is AB? AB equal to 4 whole square. So this is the 9 and this is the 16. So this is the 25. Now 25 can be written as 5 square. Okay, understood? So look at this. OB square equal to 5 square. So look at this. Here OB equal to 5. Therefore magnitude of displacement is equal to 5 kilometers. Understood? Next. Now speed. Speed is the rate of change of distance with respect to time. So look at this. Speed V equal to, this is the S by T. That is distance covered by a particle in time T. Okay. So speed equal to distance by time. Now on cross multiplication, S equal to V into T. So look at this. Distance equal to speed into time. Okay, remember it. Again, from this relation, we can also write t equal to s by v. That is time equal to distance by speed. This is the distance divided by speed. So this three relation is very important for you. First of all, speed equal to distance by time, distance equal to speed into time, and time equal to distance by speed. Okay. Now average speed. Now average speed equal to total distance divided by total time taken. Okay. Total time taken. Now look at this. A moving particle moves s1 distance in time t1, s2 distance in time t2. So what is the total distance? This plus this. What is the total time taken? This plus this. So look at this, average speed becomes, look at this, this is the s1 plus s2 divided by t1 plus t2. Now look at this, as the particle moves s1 distance in time t1, so from this relation speed v1 equal to s1 by t1, and from this relation speed v2 equal to s2 by t2. Now we have to calculate average speed in equal time. If time is equal, then t1 equal to t2 equal to t. So t1 equal to t2 equal to t. Now if we put the t1 equal to t2 equal to t, we get average speed equal to, look at this, this is the v1 into t, this is the v2 into t, divided by t plus t. So look at this, t get common, v1 plus v2 divided by 2t. Now t cancel out. So this is the v1 plus v2 by 2. So average speed in equal time is equal to v1 plus v2 by 2. Okay. Now average speed in equal distance. Look at this. If s1 equal to s2 equal to s. So if we put the value here, s1 equal to s2 equal to s. Look at this, we get s plus s divided by s by v1 plus s by v2. Look at this, ss is the 2s. Now this is the s common, 1 by v1 plus 1 by v2. Okay. Now s and s cancel out. So look at this, the average speed in equal distance, this is the 2, here LCM v1 v2, and this is the v1 plus v2. So this is the 2 v1 v2 divided by v1 plus v2. Okay. So look at this, the average speed in equal time is v1 plus v2 by 2, and in equal distance 2 v1 v2 divided by v1 plus v2. Okay. Understood? Now next. Now instantaneous speed. Instantaneous speed is speed at a certain instant. That is, if the time interval is very small, then the ratio between distance covered divided by small time interval, this is known as instantaneous speed. Now velocity. Velocity is the rate of change of position in a given direction. So it is a vector quantity. Therefore velocity v equal to s by t. Okay. Now uniform velocity. If the velocity of body is constant in time, then it is called uniform velocity. And if the velocity is not constant, then it is called non-uniform velocity. Okay, suppose a particle moves in a straight line path in the same direction. Suppose in 1 second it covers 2 meters. In next 1 second it covers 2 meters. In next 1 second cover 2 meters. So look at this, in every 1 second interval it covers 2 meter in the same direction. So it has uniform velocity. In the same time interval, if it covers different distance, then it is the non-uniform velocity. Okay, now if the velocity of a body increases from u to v at the constant rate, then average velocity becomes u plus v by 2. This is very important for you. Now, difference between speed and velocity. First of all, speed is the distance traveled divided by time taken. Velocity is the distance traversed in a given direction divided by time taken. Speed is the scalar quantity, velocity is the vector quantity, as it has both magnitude and direction. Average speed never be 0, but average velocity may be 0. Okay, now some question related to speed and velocity. Under what condition the magnitude of velocity and speed are equal? If the particle moves in a straight line path in same direction, then magnitude of velocity and speed are equal. Okay, what is the nature of the path if the particle has uniform motion? If the particle has uniform motion, that is uniform velocity, so its direction never changes, so its path becomes straight line path. Okay, during experiment, a signal from spaceship reached the ground station in 5 minutes. Find the distance of spaceship from the ground station. Now look at this. We know distance s equals to speed into time. Now here speed is equal to 3 into 10 to the power 8 meter per second, and time t equal to, this is the 300. So total distance is 9 into 10 to the power 10 meter. Understood? Next. Now look at this, a numerical. The odometer of a car reads 200 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed. Now look at this, here distance covered is equal to final reading minus initial reading. So look at this, this is the 2400 minus 2000. So look at this, this is the 400 kilometer. Okay. Now time taken is equal to 8 hours. So look at this, average speed v equal to, this is the s by t. Look at this, s is the 400 kilometer and t is the 8 hour. So this is the 50 kilometer per hour. Understood? Look at this, an object travels 16 meter in 4 seconds and another 16 meter in next 2 seconds. Find the average speed. Now the formula of average speed is v equal to, this is the s1 plus s2 divided by t1 plus t2. Okay. Now look at this, s1 equal to 16 meter, s2 this equal to 16 meter, t1 this equals to t1 and t2 is equal to t. Okay. Now look at this. So average speed, this is the 16 plus 16 and this is the 4 plus 2. So this is the 32 by 6. So this is the, look at this, this is the 16, 3. So this is the 5 whole 1/3 meter per second. Okay, understood? Next. Look at this. Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute by swimming from one end to other end and back. That is, look at this. This is the swimming pool. He starts from here, then again here. This is the 90 meter and this also 90 meter. Look at this, the average speed. Here average speed is equal to total distance. So look at this is the 90 meter and again 90 meter. So this is the 90 meter plus 90 meter. Now time taken is 1 minute, that is 60 seconds. So look at this is the 180 by 60, 0 0 cancel out. Now this is the 3, so average speed is 3 meter per second. Now what is average velocity? Here initial point and final point same, so displacement is 0, displacement 0 divided by time taken, so is the 0. So average speed is 3 meter per second, but average velocity is 0. Okay. Joseph jogs from A to B of 300 meter length in 2 minutes 30 seconds and turn back from B to C of 100 meter in 1 minute. We have to calculate the average speed and velocity from A to B and average speed and velocity from A to B and then C. Okay. Now first of all, in the path A to B, look at this is the straight line path, motion in same direction, so average speed and average velocity are equal. So look at this is the average speed equal to average velocity, this equal to, look at this is the total distance 300 meter by, look at this, 2 minutes 30 seconds. 1 minute equal to 60 seconds, 2 minutes 120 seconds plus 30 seconds, that is 150 seconds. So this is the 150 second. This is the meter. So this is the 2 meter per second is the magnitude of average velocity is equal to the speed. Okay. Now average speed, look at the average speed in the path A to B, then C is the, look at this equal to, look at this is the 300 meter and this is the 100 meter. So the total distance 300 meter plus 100 meter and time, look at this is the 2 minutes 30 seconds plus 1 minute, so 3 minutes 30 seconds. Now 3 minutes means 3 into 60, that is 3 into 60 plus 30. Now this equal to 400 divided by 180 plus 30, so this is the 210. Now this and this cancel out, so this is the 40 divided by 21 meter per second. The displacement means the shortest distance between initial point and final point. Now look at this is the 300 meter, this is the 100 meter, so this is the 200 meter. So shortest distance is 200 meter and time taken same, so this is the 180 plus 30, so 210. So this cancel out, so 20 by 21 meter per second is the magnitude of average velocity. Okay, understood? Now next, from home to school, the average speed of Abdul is 20 km per hour. In return journey, the average speed is 20 km per hour. So look at this, during home to school and school to home, the distance are same. We have to calculate average velocity. So average speed V equal to 2 into V1 V2 divided by V1 plus V2. Now put the value of V1 and V2. Now look at this is the 2 into 20 into 30 divided by 20 plus 30. So look at this is the 1200 and this is the 50, cancel out, so this is the 24 km per hour is the average speed of Abdul. Okay, Now next. Now acceleration. The rate of change of velocity with respect to time is called acceleration. Suppose a particle has initial velocity u in a straight line. After the time t, its velocity becomes v. Look at this. At this point, velocity u. At this point, the velocity v. Now, time taken to change its velocity from u to v is t. So, acceleration a equal to change of velocity, that is v minus u. So, this is the v minus u divided by time. Okay. Now, multiplying this, v minus u equal to at. So, v equal to u plus at is an important relation for you to solve the velocity of a particle after given interval of time. Okay. Now, retardation. If the particle moves with decreasing velocity, then rate of change of velocity is called retardation. Retardation is the negative acceleration. Now, difference between acceleration and retardation. Look at this. Acceleration may be positive or negative, but retardation always negative. Okay. Now look at this, a numerical. The velocity of a particle becomes 6 meter per second from rest in 30 seconds. Find acceleration. Now look at this. Here the initial velocity is rest. So look at this, here u equal to 0. Final velocity v equal to 6 meter per second. And time taken to reach this velocity, this is the 30 second. Okay. Now we have to calculate the acceleration. Now acceleration a equal to, this is the v minus u by t. So look at this, this is the 6 minus 0 divided by 30. So this is the 1 by 5 meter per second square. So this is the 0.2 meter per second square is the acceleration of the particle. Okay, understood? Now next, when will you see a body has uniform acceleration? Number 2, non-uniform acceleration. If change of velocity be uniform in equal time, then its acceleration is uniform. Suppose a particle changes velocity 2 meter per second in every second, then its acceleration is uniform. That is, the velocity of body initially suppose 0, so after 1 second its velocity becomes 2. After 2 seconds its velocity becomes 4. After 3 seconds its velocity becomes 6. After 4 seconds its velocity becomes 8. Understood? Now non-uniform acceleration. If the change of velocity of a body is not uniform in equal time, then its acceleration is called non-uniform acceleration. Okay. Now next, look at this. The velocity of a bus decreases from 80 km per hour to 60 km per hour in 5 seconds. What is the acceleration? Now, first of all, we have to calculate the velocity in kilometer per hour to meter per second. So look at this, this is the 80. If kilometer is converted into meter per second, we have to multiply 5 by 18. So look at this, this is the 5 by 18 meter per second. So look at this is the 400 divided by 18 meter per second, that is 200 divided by 9 meter per second. Okay. Now v, look at this, v equal to 60 into, now kilometer per hour is converted into meter per second. So it should be multiplied by 5 by 18. This is the meter per second. Now look at this, this is the 300 by 18 meter per second, that is 150 by 9 meter per second. Okay. Now acceleration, look at this, acceleration equal to v minus u divided by t. Look at this, v equal to 150 by 9 minus 200 by 9 divided by, look at this, 5. Now 150 minus 200, so this is the minus 50. So this is the minus 50 by 5 into 9, that is minus 10 by 9. So acceleration A equal to minus 1.1 meter per second square. Okay. Now next, look at this. A train starts from a station and gains velocity 40 km per hour in 10 minutes. Find the acceleration of the train. Now first of all, the velocity v is 40 km per hour. So kilometer per hour should be converted into meter per second. So look at this, v equal to 40 into this is the 5 by 18. So this is the 200 by 18. So this is the 100 by 9. This is the meter per second. Okay. Now look at this. Here u equal to 0 and t equal to 600 second. Okay. Now acceleration A equal to v minus u divided by t. This is the 100 by 9 minus 0 divided by 600. So look at this, 0 0 cancel out. So this is the 1 by 54 meter per second square is the acceleration of the train. Okay. Now next. Now this is the last numerical. The velocity of a free falling body becomes 60 meter per second from rest after 6 seconds. Find acceleration. Now here u equal to 0, v equal to 60 meter per second, t equal to 6 seconds. So look at this, we have to calculate acceleration. Now a equal to, this is the v minus u by t. What is the v? V is the 60 minus 0 by 6. So this is the 10 meter per second square. Okay, understood? Now circular motion. If a particle rotates in a circular path, then its motion is called circular motion. Now a line which is perpendicular to the plane of rotation and passing through the center is called axis. In circular motion, axis is same as direction in linear motion. Now look at this. In circular motion, velocity changes at every point. Look at this. Here direction of velocity changes every point. If speed of rotation be constant, then this is known as uniform circular motion. In uniform circular motion, look at this, in a force always acting normal to the direction of velocity of the particle. Now look at this, at this point also force acting normal to the direction of motion. Here also force acting towards the center normal to the direction of motion. This force is called centripetal force. Now for every circular motion, centripetal force required for the motion of the particle. Now an acceleration known as normal acceleration or centripetal acceleration is acting normal to the direction of velocity. Look at this, if r be the radius of the circular path, then total path is 2 pi r. So if v be the speed of rotation, then v equal to 2 pi r divided by capital T, where capital T is known as period of rotation. So capital T equal to, this is the 2 pi r by v, and frequency of rotation f equals to, this is the inverse of time, equals to v by 2 pi r. Okay. So now there is important point, in uniform circular motion speed constant but velocity changes at every point, and in uniform circular motion acceleration is directed towards the center and velocity is tangent to its path. So the angle between the velocity and acceleration this is 90 degree. Okay, now a numerical. The length of second hand of a clock is 5 centimeter. Find speed of its tip. Look at this. Suppose this is the second hand of a clock. Its length is 5 centimeter. Its turn in a circular path with time period t equal to 60 seconds. You know, in 60 seconds, second hand of a clock turn one round. So its time period t equal to, look at this, this is the 60 second. Now what is the speed of its tip? V equal to circumference 2 pi r divided by t. Now this is the 2 pi, t equal to 5 centimeter, and this is the 60 second. So look at this is the 10 pi by 60, this is the centimeter, this is the second, 0 0 cancel out, so this is the pi by 6 centimeter per second is the speed of the tip of the second hand. Okay, now first question, there will be acceleration when velocity 0. Yes, during vertically upward motion of a particle, the velocity of the particle decreases due to acceleration due to gravity. The velocity of the particle decreases due to gravity. Now, at the top point of its journey, the velocity is momentarily 0, but acceleration due to gravity is 9.8 meter per second square vertically downward. So, when velocity 0, acceleration may be present. Okay? When speed of a particle is constant, there will be an acceleration. In uniform circular motion, when a particle rotates with constant speed, it has acceleration known as normal acceleration or centripetal acceleration towards the center of the circular path. Okay, there is an acceleration normal to the direction of motion? Yes. In uniform circular motion, the velocity directed tangent to the circular path. In uniform circular motion, velocity directed tangent to the circular path and acceleration directed towards the center. So this angle is 90 degree. So the angle between velocity vector and acceleration vector may be 90 degree. So angle between acceleration vector and velocity vector is 90 degree in uniform circular motion. Okay, look at this. An artificial satellite revolves around a circular path of radius 42250 km in 24 hours. We have to calculate the speed of rotation of the artificial satellite. We know the speed of rotation v equal to the total length of the orbit. So this is the 2 pi. Look at this. This is the radius of the orbit. So total length is the circumference, that is 2 pi r, and 2 pi r. So the speed of rotation, this is the 2 pi r by t, that is 2 pi into, this is the 42250 divided by 24, this is the kilometer per hour. Okay, now this almost becomes 11055 kilometer per hour. Okay, understood? Many thanks for watching this video. Hope this video will be beneficial for you. This video gives a concrete idea about the motion of a particle, and you can easily calculate of velocity, speed, average velocity, average speed, acceleration, distance and displacement. Please like, share and comment on this. And if you are new, please subscribe my channel for further new video.